So, welcome everybody. Um, we are here in this new course, online course, in a partnership with New Media Manitoba, as you can see here in the screen. We have been developing this course for you guys, and the idea is while we are on all this pandemic, we try to keep connected and keep learning, even though like things are going hard. We just try to maximize our time and try and learn and keep together as a group, as a community. Um, for those ones that doesn't know me, I'm Gabriel Lascano. I'm a game developer that works at BitSpace Development. So I'm here in Winnipeg since 2017, and I had the great chance to meet New Media Manitoba, like people like Jonathan Lee, who are great. Like this community is awesome, and I want to really thanks them for letting me give this course. I'm very excited. I hope a lot of people found it interesting. So yeah, let's get started with the course. So the idea of this course, here is my website, just in case you guys don't know me and you wanna just know a little bit more about me. It's not fully finished. Of course, like a developer will never finish his projects because of time. But like if you wanna come here, it will be a great place to know me and to know what I've been doing for a while. So I have prepared like in a short time this course um, for you guys, and the idea is gonna be a little bit basic. I want to start like from the very beginning for those of you that are very interested in the game development community. I know sometimes when you start talking about games, like it's very exciting. I was like that one time. It's something that passionated you a lot. You are so like into it, but sometimes you don't know where to start or how to start. Like you might think this is something so complicated, so hard. And this series will help you to like break that barrier. Um, in the community from New Media Manitoba, there's tons of like events, and one of them is the Game Jam, which I really like. Um, I'm gonna try and post more of my game jams that I've been doing here in this website. I have posted a couple, but like it takes time to like build again and have everything done. So these great places, sometimes you feel a little bit overwhelmed, and you get to the place and you don't know how are you gonna be able to fit in there because you don't have enough skills yet or something. So this course is something that will help you to give you those tools, so you are able to go into one of those game jams and be ready to partner with someone and do a game. One of the things that you are never taught, or like it's very common to miss, is how to work in a team, how to collaboratively work doing not just a game, like even like software development, but especially in games, no one tells you how do you get that project to work with more people together, which is very important because it's not easy to have all the skills necessary to build a complete game. So you often will want to partner with someone else that will have like those different skills. So in my case, for example, I'm not an artist, so I won't be able to produce the assets. I will be able to get a game going, like do all the programming and everything, but it will be with like random assets. So that's why I always, when I go to a game jam, I like to partner with a lot of artists. Sometimes I get too many of them, but it's never like too much, trust me. And it's great. But at the beginning, when I started developing on Unity, it was a challenge to collaborate because there was nothing at the time. Well, there was, but it was not very open, and I didn't know it at the time. It was hard to see how can we manage these versions and like merge them together. So what we ended up doing at the time, which is pretty funny, is that we started developing each member on its computer, and we will just like kind of make the changes into a USB and pass it to someone. Often it was me. I will have to just plug the USB, put it in my computer, open the project, and try to figure out how to merge all of those. It will take me a lot of time and a lot of troubles, and we will lose tons of progress every time we do that. So that's why I want to start from the very beginning with how to collaborate when you are doing a game jam. How can you set up an environment where you are able to share your content, your progress without losing everything? So today, like this course is gonna be about that, like how to build a basic 2D game, platform game, and then most importantly is how to keep it um, with your collaboration tool. So in that way, you will be able to partner with other people and work together. The course will be breakdown into like 4 weeks. This is the first one. This is the only week that we'll have 2 days. That's why it's because today I wanted to give you like an introduction and start talking all about the collaboration and the version control. And on the next session, we will start like diving into Unity. So today I want to give you a brief description of what's the course about and start working on Git. So to start, yeah, this is a partnership with New Media Manitoba for doing this course, and I did like a learning outcomes, which will be learning what's a versioning control tool, and which will be like kind of the best practice in the basic use of this tool. I will teach you what's the basic on Unity and on the Unity game engine, like from the beginning, because not everybody knows it and not everybody has ever played with it. And I wanted to start from the beginning so everybody can jump right away when they go to a game jam. We will do like a 2D game, which I will show you in a moment. It's not finished, but it's something that we will be doing. So we will program all the player, we will use some assets that I will give you, and we will like learn some of the basics of Unity on how to do a 2D game. All right, so to start, also, if you have any questions, please feel free to ask me in the chat. I will be more than welcome to answer it right away. I want this to be a little bit dynamic, so if you have any questions, I will be glad to answer. So let's start talking about like version control. So for that, most of people maybe don't know what's version control. So in like in software development, you need to have a way to keep your version of your program like somewhere. So that's why the version control, or known as well as a revision control or source control, is a tool that helps you to build like branches and like a history of your changes. That it's very powerful. Once you start seeing it, you will see it's amazing. It's something that will change your life when you are developing. At any given point in time, you will be able to just like roll back to a stable version and go from there. So in game development, this is awesome because sometimes in Unity, and this will happen a lot, you will be working. Okay, we have a question here. Yes, there will be. I'm recording this session right now, and then John will also post it. He will give you more details about it. But yeah, sure. Like if someone missed this, they will be able to just go ahead and watch the recording. Thank you for the question. So yes, so with version controlling, you will be able to go back. So as I was telling you, in Unity, a lot of things happen, and you sometimes when you um, don't have too much experience, or even when you have a lot of experience, um, so when you don't have a lot of experience, you might end up having a lot of troubles, and you will just wanna roll back and go back to where it was working. And version controlling will let you do that. But most importantly, version controlling is also often used for collaboration because it lets you use this tool to work collaboratively with more than one developer or artist or your team, basically. So I want to start talking about Git. So as I'm saying here, Git, and there's a quote from their website, is a version control system for tracking changes in your source code during software development. So what it's good about Git, well, Git is so popular, is huge, um, and it was created by the guy that was working on the Linux distribution because he was having some troubles with his version control tool. So he created this one, and it became like huge. It's amazing. Yes, so here I have created for you guys the like this little tutorial. Like this website basically has the tutorial of what we will go through. But yes, those links that you are posting there, thank you so much, will help you guys throughout this. So why using Git is because it's very powerful, and it's basically what I will recommend you guys to use. And this will help you to achieve that collaboration that I'm talking about. All right, so let's start on this. So I have prepared this website with uh, like some like instructions on how to start with Git on your computer, either if you have Windows, Mac, or Linux. It's pretty easy once you know what you're doing, but if you don't know, it could be a little bit like overwhelming. But basically, what we want to do is we want to install Git in your computer, in your machine. And for example, in Windows, it's pretty easy. You just have to download it from the website, the one that they posted there as well, and then just follow the instructions. Um, Once you finish that, this is a like an extra step that I recommend doing. It's not like mandatory, but it's good to have, and it's setting up your like global variables like your name and your email. This is because every time that you will push, and then we will get a little bit more into what's a push, but like when you submit your changes, your code, uh, no. So do the Mac OS have to have an Intel chip? Nope, not necessary. This will run independent on which chip you have. Um, it's for all platforms. I have used it on different type of machines, and it works perfectly fine. That's a valid question. So, yes, I was telling you, like on each push, it needs to know from who did that push came from, right? So it's good to have your name and your email just in case. So I will recommend all of you guys to, once this is finished, and if you want to go through this website or the video, you can go ahead and give it a try yourself. Try to install on your machine. If you have any troubles, please feel free to contact me. I will be more than glad to help you set it up. As I told you, like it's pretty straightforward if you follow these steps, but sometimes it could be a little bit overwhelming. Okay, now the next step that I consider important for this course is that you with Git you will be like pushing code to somewhere, right? Um, Initially, when you use Git, you can use Git just for like your internal version control. So you are able to just have a local version of Git, which is basically what it is. Git is just a local version control to keep track of your changes on your code. Um, but of course, what we want to do is to use it like online, right? Like in the cloud, basically. So we need to use like third-party companies to be able to do this. Um, for this case, I'm using GitHub. I will go a little bit in depth on this on the next step, but I want to explain you why we want to generate an SSH key. So because our code will go into the cloud, basically into a server from a third party, we need a way to authenticate ourselves when we are pushing our code. There's a couple of ways to do it, or well, there's actually two ways to do it. Um, and is through an HTTPS link, basically, where you will be able to just like push your code there, and you need to give your credentials to log in and to and like your login and password. Um, so once you do that and you're authenticated, you are able to commit your changes. The Git projects, like your projects, could be private or public. So if you have a private project, which they are called repositories, um, you want everybody that is gonna like access them to have access to it, right? Like if your friend, your partner, your team is going to access that code, they need to authenticate themselves. And I think that the best way to do it is through the SSH keys. So I have here a little like phrase, like paragraph of what's an SSH key. And it's basically just an access credential using the SSH protocol. And this is basically having two keys. One is a private and one is a public. And just those two systems that have those two keys will be able to authenticate themselves. So that's why I will generate one key for myself, which is the private key, which I only have, and the other one will be given to that third party. I will give it to them, and every time that I commit, they will compare that key to see if I am who I'm saying I am. And that way I will be authenticated right away without having to prompt any username and password. So as well, for this, I set it up some instructions for all the operating systems on how to generate your SSH key. Again, this one might be a little bit more complex. If you don't really want to do it, you can like just jump this step. Like you need to get Git, but this is like kind of optional. I will recommend doing it, and it's a good example for you to like start getting familiar with the command line. It's a pretty good exercise. It's not something very difficult to do. You will have to just like uh, take like put these commands in your command line, which for those of you that don't know it, like it looks like this. That little scary black window is very useful, and when you're using Git, you will see it pretty often. So I will recommend you guys going through this tutorial and getting your SSH key. Okay, so now I was talking about GitHub, this little cat here. So GitHub is one of the biggest companies that provides hosting for software development version control using Git. That's why we are using Git as well. I like GitHub a lot, but it's not the only solution available. For example, there is Bitbucket, this one right here. There is GitLab as well. For this one is often used as well for enterprise purpose. But I really like GitHub, and for the sake of this course, we will go through it. So if you want to know more about it, here is a link to the website, and I recommend you guys like getting an account on it. I set it up here as well, like a quick tutorial on the next step we're gonna follow. So once you have created your account and you sign up into your account, the next step will be to set up your SSH key that we just created. So in that way, GitHub will know your computer basically. So every time, oh yeah, that's a great comment. So recently, it was last year, they made the private repositories free. So for a long time that I've been using GitHub, I was paying for the subscription to have all my repositories private when I was working on my private projects. But last year, that was like a huge deal for me and for a lot of people, I will say. Um, GitHub made their repositories, like their private repositories, free, so you don't need to pay anymore for it, and it's great. So it's awesome for you guys to try it out. Once you are logged in, we want to set up our SSH key. So we will go to this screen, like you will log in, like it looks something like that. You will go to settings. Then the idea is to go to SSH and GPG keys. And once you're here, you will want to add a new key. So the way to add this new key is pretty simple. I just put the 3 steps that you need to do. First step, just give it a name. Like the title doesn't really matter. It's something for yourself to identify this key. So if it's your home computer, you can just name it my home computer, or if it's your laptop, your laptop. But the idea is that you will paste your SSH key here, and your public SSH key. Don't paste the private. So there's a couple of ways to get that public SSH key. One way is using the command line. So as well, if you feel like trying the command line, I posted here the 2 ways from Windows or Mac on Linux, because it's the same, on how to get and copy that SSH key using the command line. But if you prefer, you can just go out, like on Windows and Mac. You can go to your folder. It's usually gonna be on C and your user, and then you will have to go to SSH, and here you will have your public key. Most likely this folder, the SSH folder, is gonna be hidden, so you need to show your hidden folders. And I have a couple of, like the 2 necessary like ways to do it. The links here. Because sometimes people don't know how to show the folders, and it's pretty normal. Like even on Mac, it's not as straightforward as you will think. Okay, so once you get your SSH key, you will just copy it here and you will add your SSH key. And that's basically what you will have to do. Okay. Thank you so much for joining us. And yeah, if you want to keep looking at the course, it's going to be recorded and you can check it out later. But awesome. Thank you for being here, and see you on the next one. All right. So if we keep going, we have done so far installing Git, getting our SSH key, and created an account into GitHub, and set it up our SSH key into GitHub. If we have this and it's already done, you will have your system, your computer, connected into that third party to commit your changes, your software. So let's go a little bit and talk on what is what I'm talking about, like what's a repository and what's all of that. But for that, I want to use a user interface that will help us a lot at the beginning to understand what I'm talking about, because Git it's something that runs in your machine, but you don't see much of it. When you use the command line, you basically just give commands and you give a little bit of feedback, but you don't see much. So if you are not very into development, or even like some developers have never done this before, I encounter that pretty often, you won't get it as luck. Like you won't get it as easy. So I wanted to give you guys an option. Like, of course, if you want to use the command line, I also 100% encourage you to do it. It's gonna be the most complete. Is not gonna have any troubles. Is gonna be the best way, but it's gonna be a little bit more challenging. If you wanna go for more user-friendly, basically solution, I will recommend getting in one of these user interface programs. So my key like solution for you guys is Git Kraken. Unfortunately, they recently just like removed the private repositories as from the free license. So now you will have to pay if you want to use the private repositories. Um, but otherwise, this tool is amazing. It has been so good. I feel like that's why they have made it not free anymore, because it's so good. But there are some alternatives, which I also posted here. One of them is SourceTree. If you want to check it out, it's completely free. It's for Windows and Mac, and you can use it. It's free. Like, and I know a bunch of people, and I have used it myself as well. Uh, my personal opinion, this is just myself. I don't like it too much, but it will do the same. Like, it will do the work. And another solution, which I prefer more than SourceTree, and it won't cost you, is GitHub Desktop. And so to keep it in line with GitHub, you can use GitHub Desktop. The only downside is that, well, is from GitHub as well. So you will be like getting stuck with GitHub on everything, which is not bad, but like is something just to consider. That's why, for example, we are using Git as our version control for projects in Unity, because as maybe some of you know, Unity has something called the collaboration tool, which is basically a version control system that they have for Unity specifically. The problem with that is if you wanna tomorrow go and do something that is not in Unity, maybe it's in Unreal, or you wanna do a website or just a web application or whatever, you won't be able to use that Git like that version control because it's from Unity. But if you use Git, it will work for everything. Like you can do it for every single thing, and we will see it shortly. Okay, so I'm gonna just start first showing you guys Git Kraken. I have installed GitHub desktop as well, just so you guys can see it, but it's pretty much the same. So we will go with Git Kraken so I can explain you what's version control, and it will be way easier to understand what I'm talking about. Okay, so here we have a little bit more of something to check out and see what is going on. I believe there it is. Good. Okay, so this is our interface. Once you connect, like once you open it, you will be able to log in. You can either create a new account for Git Kraken. You can use your GitHub account, which I recommend. That's what I do as well, and it's pretty good. The idea of this tool is that it will make everything easy, way easier to manage your projects. So let's start talking from the beginning. When you create a project in Git, it's called a repository. Like in GitHub, we call them your repositories. So if you go here, you see I have here my repositories. So you will create your projects as your repositories. That's basically just the name of your project and some basic information about it. But this will hold everything from your project. And as I said before, it doesn't need to be for Unity. This is for everything. Like Unity is not, it's not like the Unity collaboration that is only for that. This one is for any type of software development that you are doing. Okay, so if we go here to our little tab here, we have some options. We can open a repository, we can clone a repository, or we can start a local repository. So there's like a bunch of things here we can do. And basically what it does is when you want to open a repository is just take a project that is local in your machine, that it has been already like open through Git, and it will let you like manage it. When you want to clone it is when you want to grab it from the internet, like from GitHub, for example, or Bitbucket or somewhere else. To like you can see here, you have GitHub, GitLab, Gitbucket, Azure DevOps. So you can grab it from there and like clone it, or you can just start one local. So I already have one project here open, which is the one that I was working on, which, by the way, we can just check it out. No, we will go here and then we will check it out. So this is how it looks at project when once you open it and already has some things. You will have like kind of these three columns where you have all the information of your project. This left column is telling you like the information about your repository. So as I told you, like you will always have a local version of your project, and it's here, and it's called master. Git, as I told you before, it manages branches, and we will go a little bit more into that in a moment. But for now, what you need to know is like every time that I create a project, it will be created with the master branch, like is the middle, like all my project will be there. So I have my local repository, and it has the master branch. And this project is connected to a remote repository. And it has the origin and the master branch. So basically these two master branches are kind of connected. So I can see my progress locally, and I can push it remote. Or if someone else makes any changes on the branch, on the remote repository, I will be able to see it and pull it from here. There's some pull requests. I'm not gonna go into it on this tutorial because that's a little bit more in depth and talking about like GitHub and Git. But it's basically just a quick note on it. Is when you have a project out there and there's a lot of developers that are making changes, you don't want them all to just like throw them into your project. You want them to just make a request so those changes can be merged into your project, but we don't need to go into it. The tags as well, we are not going to use them for now. That's basically how like making some tags in your comments, but that's something that we will cover in a next course. So models the same. This is very powerful, and I use it a lot, but for this course is not also important, and same for GitHub Actions. So for here we we're only gonna care about like these two options, like the local and the remote. Then you will have your this like the middle column. In the middle column, you will have the history of your branches. So as you can see, here is where my project started. I started my project with a README that doesn't say too much, and then I started creating some more things. So how it's divided is in Git you have to commit your changes and then you have to push your changes. So all of these little lines that you see here are commits that I made when I was creating the project. So every time that you make some changes in your project, you want to create a commit. For example, here I did the enemy controller, which basically has a script for the enemy controller, and I push that commit. This helps yourself in the future to see what happened. Like for example, I want to know, oh, when did I make the enemy controller, so I can go back and see, here it is, and I can check it out. I can open and I can see what it's about. But also is very powerful when you are working with a team, because in that way, when you are working with someone, before you do anything, you can see what the other people have done, and you can check, oh, they made the checkpoint logic, is this okay, so I can keep working. Because the main conflict that we have when we work in a team is that sometimes we will be working on the same thing. That's a problem, right? Because if you are working on the same file or something as another person, then how can you merge those things? So for the most part, it's a little bit easy to merge those conflicts, they're called. But in Unity, because we have a lot of files that are not just scripts, sometimes it's a little bit hard. That's why we need to be careful on what we commit, because we don't want to override what the other developer did with our changes, or we don't want to get our changes overridden by the changes from another developer. So we gotta be very careful. So yes, here we have all of our commits and everything, and we can see here that we are on the master branch. Here we have some buttons. I will go at the end, but on your right hand, you have kind of like your previewer of those commits. So I can see what I have done on each commit, and I can click it. I can check what I changed. It gives me the commit message at the description if it has, who did it. That's why it's important to have the name that I told you to set up, and the email, just in case you need to know who did this, and it will give you the time and everything. Here, most of the times you will get it like this. I would like to use it in a tree because it gives you the folder structure of the changes. So that's pretty neat. Okay, and now let's go here into the top bar, which is the tools that you will be using while you use Git Kraken and basically Git. So what you always want to do before you push any of your changes is you want to push. What you can pull. What you can do is you can fetch first. This what we'll do is we'll bring, in case there's are some commits that are not shown here. So for example, I can go here. Let's go to that project, which is somewhere around here. Sorry, I don't see. Oh, sorry, here. So I'm just gonna go into the README and I'm gonna edit this file here, like assuming it was another developer testing on the tutorial. So as you can see, I'm changing just a file. I'm gonna go ahead and say I'm update the readme file. And if I want a description, just in case, this is just a test to check the commits on Git Kraken. I can say I want to commit it directly to the master. We are just gonna look at this. We don't care about the other things, and I'm gonna hit commit. This will make the change. So you see it here. Now my README has this change. If I go to my local computer, like Git doesn't work automatically. If I go to my project and here, and I open my README, you will notice that I don't have that change that I just made, right? So I will have to go into Git Kraken, and you see, I didn't need to do the fetch. That's pretty much the cases. You don't need to do fetch unless there's like a huge change or your internet is slow. It will show you that, okay, look, someone did an update in the README file. and I can see what they did. It's telling me that it was committed by me through GitHub, and it says update the README file. This is just a test, blah blah blah, the description, and I can see what's the change. I can see, oh, okay, they changed that README, and I can pull that change. So pulling that change, what it will do is it will bring those changes into my local version. So now if we go back into our README, you will see here is my testing on the tutorial. Nice, right? Like, this is pretty good. So imagine you are doing lots of things with a lot of teams, like with your team, and you will be able to get those changes just by hitting that button. Now let's do the same, but we will do it like the other way. So here we will say thanks for the changes on the README, which I will then remove. But you see, I saved it. As soon as I saved it, Git will like recognize, oh, you did a change. So the changes here will be shown when you made them. So let's go ahead and I'm gonna make a new file here, test file, and this is test. Save, and I'm gonna close it. You will see here I have these two files. So whenever you see this green plus, it means that I created that file. It's something that didn't exist in the origin remote repository, and I created it in my local. And this one, when it has like that yellow pencil, it means that I just edited a file that already existed. There's a red one, I'm gonna show it like later, that means that you deleted. And there's a blue one that means that you moved, you just moved the file from one location to another. All of these changes are tracked by Git, which is pretty good for you because you want to keep everything consistent. So what you will usually do is, okay, yeah, I see these changes. You want to make sure you made these changes because Unity, as it is too powerful, it sometimes creates a lot of things in the background that you probably don't want to commit sometimes. So make sure that you always check what you are committing. So in this case, I know I created this file, so I'm gonna stage it, and I also changed and I modified this file, so I'm gonna stage. So what I do first, I stage my changes, and then I can add a message. So I will say this is just a test, and I will remove later. And I can hit commit. When I committed, it's just going, as you can see here, that the little like PC icon is just going to my local computer, to my local branch. So those changes are saved in my computer, but no one else knows them. Like if I go again here and I refresh this page, no changes have been made. That's because I need to push them if I want them to be on the server. But remember, before you push, you will always have to pull. These are like the best practice I was talking. So you make sure you first maybe fetch to see if there was any change. Maybe they change exactly the same that you change here. So you don't want to send the same change or maybe override something that someone else did. So you make sure there's no changes, or if it is and you want to check, you can just pull, and it will like this will make a merge to see if everything was right. In this case, because there's nothing else, it's good. We will do maybe another test later where I will change something and it will make a merge conflict. Okay, so now that I'm sure that I did this and I want to commit it, I just have to hit push, and it will take some time and it will be there. And if I go back here, I will see my new line. Awesome. So now we know how we can pull, push, and like basically work with Git. So that's the basic. If you know this, like up to this point, you will be able to have a version control of your software and keep track of all your changes. And like you can do it and you can work with someone else because you know how to pull and push changes. Let's say, for example, I want to go back. I want to see how the README was, of course, something more interesting than that. But I want to see how things were at the beginning, right? So, for example, let's say um, I want to go. Okay, yeah. For this, I'm gonna show you guys the project that we will be working on, so I can have like way better examples. So let's go into the website. Here is the end of this part of the tutorial. Then we will go to the part two, but that will be next week. But for now, we can head into the game that we will be developing. So this game that we will be doing throughout this course, and of course it's not finished. We need to complete this game, but basically this is what you will be having. It's a 2D game that you can completely expand. This is just like one part of a level. You will be able to move your character using the arrow keys. He will be able to walk, he is able to jump, right, and he's able to attack. You will have some health. You will have some enemies. You will have some platforms. You will be able to fall, and you will be able to respawn in your like checkpoints. The enemies are able to like attack you and deduct some life from you, and you will be able to attack those enemies and try and to kill them without them killing you, so they will die, and keep moving to your next level. Of course, this is just the beginning. We will like improve maybe the UI as well. Depending on how time goes, we will add way more features, but you will know the basics. Like this is what Unity, like what I call the basics you need to make another game. I will teach you the logic on how things work on Unity, on how you can make a player like walk and move into in the world, and how to interact with things. Because as you can see, he is like walking in the surface, like moving, right? Okay, so now that we have that, let's jump into Unity. So this is Unity. I'm not gonna explain you right now anything about it because I wanna leave that for the next session. But today what we are gonna do is I wanna show you guys some of the Git like powerful tools that we have. So we have this project here, and it's in the state that we just saw it in this in the website. You can see here I have my level 1 sample scene. I have a bunch of things. But what if I decided, oh, I want to see how was the game at the beginning because I had something, then I erased it, and I just want to go back and see how things were, right? Um, so one way to do it will be just to like going back, but we are gonna take advantage of the situation and we are gonna start talking about branches. So if we go here and we say, I want to go to the very beginning, like somewhere around here, to see what was happened, I'm gonna create a branch. So I'm gonna go ahead and right click, and then create branch here. I'm gonna call this testing, and this will create a local testing branch in my computer. As you can see, it's not in the remote. I could make it appear there. Like if I know this is a branch that I want all to be up there, I can do it. But for this example, I only need it like to be local. Once I do that, what Git has done is he has basically rolled back all these commits, and I'm just here. So this branch, it only knows about this commit, these 3 commits. So if I go to my folder, things have changed a lot. You can see here we have missed a bunch of things. And if I go to Unity, this is something that it has been great that before it was a little bit buggy, I will say, but once I open it, like right now it's not open, he doesn't know the changes, but once I like focus on it, he will like reload everything and it will show me how it was before. So you see, it's holding blah 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 blah. It's compiling all the scripts because we have basically destroyed for Unity all the changes we have made. So it's gonna be a pretty big rollback in time. And it's kind of like, yeah, Back to the Future, going back to see how things were in a time. I recommend, once you're like, if you're doing this, try not to do it with Unity open, just in case. For the most part, it will work, as you can see here. I'm gonna just go here and say do not save. Um, it just worked fine. You see, my level 1 doesn't exist anymore. He doesn't know it. He doesn't know about it right now, and a bunch of folders that I created before are gone. Yes, that's how it works. It's completely gone. So this is how my game looked like at the very beginning. We just have like some blocks as the level and our player. Um, and this is how our branch, our test branch looks like, because we remove everything. Um, Now let's go, for example, and say we want to keep this branch. But we don't want it like, we want to have an well, let's create a new branch. I'm gonna create just a new branch for you guys. um Here, let's say we want to create a new branch here, and this was old master, right? I'm gonna create it, and same thing will happen. Like, Git just recreated all these files into my local machine, and if I go into Unity, it will just start reloading, and it will just bring back to life all those things that we just removed from the previous branch. Uh, the previous branch, for example, what I made it for was especially for maybe going back into the past and see how some things were. Maybe I used to have a great collider, but I missed it, or I lost it in the process, and I never saw when. I can go back, check it out. I could even just like take it from there and apply it to my new project. We'll ask him to reload, and here's back my level 1 and everything. But let's say I'm here, and the two new commits are these two, like the changes on the README. Right now, what I'm gonna do is, well, first we can delete this branch. So we're just gonna right click and delete testing. This will delete it on my local because I don't have it on the remote. Delete. It's gone. It doesn't exist anymore. And here on my old master, what I'm gonna do is I'm gonna make some changes. So for example, I'm gonna go into a script. Let's go, for example, to the player controller. By the way, yeah, for Unity, you can use any IDE to like for your code. I like a lot Visual Studio. I am also gonna be making some other like tutorials and courses about how to use Visual Studio properly, because it has way too many tools that you might not be aware of, especially, for example, how to debug your code. For those one doesn't know the term, sometimes you have some troublesome bugs in your code, right? And you don't really know what's going on. You don't know what's happening, or why is it breaking, why it doesn't go through. Well, the best way is to debug it. You can do it in the old-fashioned way, which is basically adding some text, basically, on your code, so it will print into the console. I'm trying just to use some words that are more understandable, but basically, in that way, you can like troubleshoot what's going on. But the idea with Visual Studio, or it's not only Visual Studio, but I like it because it's pretty powerful for that, is that you can do some breakpoints that will let you to basically stop your code in a certain point to check what's happening. And that's amazing. Like that's so good. It will help you so much when you are working with your code, because how code works is you have these lines of codes, right? And the computer just reads them like too fast. Everything will happen in every frame, basically. We will go into that theory a little bit later on the next class, but it's hard for you to know what's happening in a certain point of time because everything goes so fast. So being able to stop the code, see what's going on, what are your variables, what is happening, it's very powerful. But well, we are here in our Visual Studio. You can also use Visual Code if you prefer so. Visual Studio also is licensed, so you will have you can use Visual Studio Community, which is free for use if you are not professionally using it or things like that. If you want to use something very similar but it's professionally wise, I will recommend Visual Code, which is the free version. It's a free version of it, which is pretty good. But there's are like a lot of different solutions out there. Okay, so if we're here and I will say I wanna add here, for example, mm, just a variable. mm, Once I add this, as we saw it before, it will be shown here that I changed my player controller and I added that line. That's why I love so much Gitkraken, because it's very visual. Like you can see exactly what I did, and other developers will see exactly what I did, which lines I added, and everything. But the good thing here is once you are here, you can see my old branch. It kind of starts diverging from the master branch. This is because I created something in the past and there's some comments in the future, basically, right? And they are not matching, basically. That's why they are called branches, because you start like branching your project into different versions of it. So let's say I want to keep that change, so I'm gonna stage it, and I'm gonna say this is just a test on the old branch. So I will commit this change, and you will see here how my old master just like skip these two commits. They don't, like, I'm ahead, but I don't have this. So remember here we have this testing on the tutorial. If I go to my folder and I open the README, I don't see that because it doesn't exist in my project right now. I diverge from the master branch and I no longer have it under my control. This is very powerful, and you will like to use it when you are doing, for example, some testing. Like, okay, we are gonna try a new like control mechanics in our game. We wanna completely change how we were using it, but we wanna test it out first. So you can go ahead and create a branch and like change everything. Maybe you just like completely break your game, but you are safe because like your original work is on the master branch and is completely safe from any harm. So that's why it's so powerful. Also, it's good because you can have multiple kind of versions of your project divided by branches. So let's say, for example, we are making this game for mobile, but we are also making it for PC or for like a web version, like as we were doing it. Those two versions will most likely look quite different, right? Because in the mobile we will need some sort of controllers, like some buttons, some UI, to be able to move. But in the web version or like the PC version, we don't need those because we have the keyboard. Um, so those differences will need to kind of exist in the game, while all the other like core mechanics exist, because the player will move the same, he will kill the same. It's not like because it's now mobile, my player will do more damage or anything. So having branches, you can have one branch which is called mobile, for example, and you can keep it up to date to the master, but you will have different controls for your game in there. So that's one of the examples where you can use branches. They are pretty powerful. Um, so yeah, that's branches. Let's, for example, now go ahead and do merge. Um, so what I want to do now is I want to merge whatever was on master with my old master branch. Why is that? Is maybe on the example that I was mentioning before. We have our new branch. We were trying just a new mechanic, and we changed a bunch of things while our team was working on other stuff. Let's say, for example, our team was working on the game design, so they keep updating the scenes and the levels and everything. But we were implementing a new mechanic on the player and the enemies. We were not sure if that chain was gonna go into the final product. That's why we made a branch. At the end, once we tested, it was amazing, and we decided we wanna merge into our core project. So in that way, what we will do is that we wanna merge master into the all master. In that way, we will keep all the changes here. You see, all those changes that I made on master now are reflected into my all master branch. So what I did was basically drag it and drop it in here, and I did merge. Of course, this is using Git Kraken. Yes, I know. If you use it on the command line, there's a command to merge. You need to say which branches you want to merge, and you use the command to merge. Or if you use a different user interface, you will have to use like different like hotkeys and things. But here in Git Kraken, you just have to drag and drop, and you will be able to merge those two branches. So if we go here, we see those changes that were on the master branch now reflected in our project, which is great. We have our project like this. Now, for example, one thing to notice is pretty important is we merged the all like the master into the all master, meaning that the changes that existed on the master now exist on our all master branch, but is not like sideways, like to the two ways around. The changes that we made on the old master, having this guy here, the change that I did on the player controller, doesn't exist on master. That's why those two branches still look like they don't exist together, or like those changes doesn't exist in master. Uh, so when you merge, you are just putting basically the changes from one branch to the other one, but it's not that both are gonna stay the same. So in the case that I wanted to have all my changes that I made on the old branch go back into the master, I will have to do the other way merge. I just want to show you guys here the test file that we mentioned before. I'm gonna move it into the assets folder. So just to show you the blue icon that I told you when you moved it. And now I'm going to go ahead and delete that file so I can show you the red icon that I was mentioning. So what it's mentioning is you have deleted this file. And I'm gonna go ahead because the red also applies for the red only applies for deleting objects, like when you completely delete something. But as you can see here, there is a red line. Um, that means I deleted that line. So if, for example, I go here and I say I don't want this variable anymore, I didn't use it, I'm just doing some cleanup in my code, and I go into Git again, you will see the change appear there, right? And my player controller will show a red line saying that I deleted that line. So we can go ahead and commit those changes or whatever. This is just like cleaning up repo. And we have here our branch. In this case, like if the master, like if the old master would exist in somewhere else, we will be able to like push it into the repo. But because it doesn't exist, it's only like local. You can see here it's only on my local. There's not much sense on pushing it, unless I create the branch. So why don't we just go ahead and do that task? So I'm gonna hit push. It's gonna tell me like, hey, in the origin, like on the remote, there's no all master. So where do you wanna push it to? So I can just leave it like this, or I can change the name. Like my local branch could have a different name than the remote branch. I won't recommend doing this. Like keep it always the same name, because then you will have some troubles remembering. So I will hit submit, and Git Kraken will automatically generate a new branch that now exists on GitHub. So if we go back to GitHub here, before I hit refresh, I hope I can see it from here. No, unfortunately. Well, here, yeah, you see. Well, it already refreshed, but before it would have been only master. Now we have our all master. So what I want to do now is we have these changes, right? And I'm gonna basically try to fake uh, a merge conflict for you guys to see what I'm talking about. So I will go here and I'm going to just quickly create down here public void test. This is just a class for testing here. This is just a test for merge conflicts, right? So I just created this line. It's just for testing. And I'm gonna go ahead and commit this change. I can see here, oh yeah, I did that. So I commit, and I'm gonna say adding add test function with a string message, right? And I'm gonna commit this, and I'm gonna go ahead and push this to my remote repository. So if I go here and I go to my code and I go to assets, scripts, and I go to player controller, you will be able to see down here. Oh, sorry, I didn't refresh. Oh, sorry, I need to switch to the all master branch. So yeah, remember we are working on the all master, not in the master branch. So as you can see, on the master branch, there was no changes because I'm not changing anything on the master branch. I'm doing it directly on the other one. So you see here my test. So what I'm gonna do is let's say this interface is like another developer. So I'm gonna go ahead and go here and I'm going to say I like conflicts. Let's do it. Right? So add more message into the test string variable. This will create a merge conflict in the old master branch. So I will commit this, and I'm going here. So this is an example where it took a little bit of time to appear. If it wouldn't appear for a while, I will have to go and fetch and see here. Um, Sometimes it doesn't appear, and that's when most of the time like developers will have merge conflicts because they don't know what the other developer is working on, because that happens. Like sometimes people doesn't have like communication, and you will end up doing working on the same thing at the same time. For example, one rule of thumb that I will give you guys is when you're working on Unity, we will cover this more next lesson, but there's scenes or like levels, like the one we saw here. There's level one. I will encourage you guys to don't work in the same level as the other developers are doing. It's just because levels, like the scenes, are a little bit harder to keep track of the changes. It's not that it's impossible, like you can get it, but if you are a beginner and you're starting right now with your team, try to just work on different scenes so you don't have these merge conflicts that will probably screw up a lot your scene. And trust me, like if you have been working a lot of time and putting a lot of effort into your scene, like your level, and someone did like some minor changes, but Git doesn't like it, and it will completely destroy your scene. So make sure you don't do that. Okay, so I have this change here. So before I do anything, like my local branch doesn't have that change, but I'm gonna go here. I'm gonna say I don't like merge conflicts because I don't like them. They are sometimes hard to deal with. So I'm gonna go here and I'm gonna see if this. So when you are committing, you will often try to see, oh, another developer did a change on the player controller. Oh, they added something into this line, and I'm going to add the same into the same line. Okay, so I can prevent that change from like that problem from happening before going into the merge conflict. And I really like encourage you again that is way better for you to like acknowledge it before, like say, oh, I added this and he added this. You can just go and talk to them. Oh, okay, why did you add it like that? Oh, okay, we know which one is the final one. There's two ways you can do to prevent the merge, like the merge conflict. The first one will be terrible, I will say, is you have to remove all your changes, basically. Just remember what you did, and then you can pull and then redo your changes. This is the worst way to do it, I will say, but sometimes people will do it. You need to go into like a common agreement, like to know which one will be the one, because sometimes it's not a conflict. Like it's a conflict for Git because it's two people committing the same line. So let's go ahead and try it. Changing the string message on the test function on player controller. So I'm gonna commit, I'm gonna pull, and you'll see pull fail, merge fail. There has been merge conflict that need to be resolved. So here is showing me we had a trouble. There something went wrong. You can either abort the merge to go back, because what Git is trying to do is trying to merge your files, and maybe you are committing more than one file, and those files, some of them can go through without any trouble. Like maybe you are committing a lot of them. That's why I also encourage you guys to commit fewer changes. Like if you commit fewer, you will have less merge conflicts. But let's say you push a lot, some of them pass, no problem, but a couple of files are broken. So Git will merge all of them, and Git also will try to merge as much as it can. Sometimes you can even have two changes in the same script, but Git is able to like merge it if there's no conflict. For example, you were changing something on the top and someone added something in the bottom, so it's completely separated. So it won't like it will be easy for Git to just okay, I'm gonna change at the top and I'm gonna add the bottom line. But when you are dealing with something like this, because you change exactly the same line, he will tell you like, oh, look, there's a conflict here. So you can see, oh, there's a conflict. If you abort, it will just go back. So let's try to abort first. Like, oh, no, sorry. I know I did something wrong. I'm gonna just remove my changes or whatever. But maybe you just no, but like everything is all right. So you will do it again. It will tell you again, hey, I keep finding a problem with your code. When you do it on the command line, you will have to basically go into your script and check what is going on. Git is pretty good with that as well, because it will add some special characters into your code. I'm not gonna go into it right now because that will be a little bit more specific and complex. And we are using a UI, a user interface tool, which will help us a lot. Um, but here, if we just click this little file, he will bring us a merge conflict tool, basically, like the internal from Git Kraken. There are other tools, and that's why here it says like I want to open in an external merge tool, because sometimes it's a different type of file, and you won't be able to see it through Git. So it's hard to forget through Git Kraken, sorry. So it won't be able to give you this. But here you will see, oh, okay, so I, Gabriel, in my local branch, did this change. I added the conflict. I don't like merge conflicts. And I, Gabriel, let's say another developer, in the origin, so this is on the remote branch, right? This is on the server from GitHub. They did a change that says, I like the conflicts. Let's do it. Git cracking is telling me this line, there's something wrong. I could do this. This is my result. Like I will leave it just as it was before. I will just remove both of you guys, or you can decide and take yours, and it will add mine, or I can take both and it will add two lines. This will result in a conflict for code. So remember, Git is not checking either if my code is running or not. Git is just checking for the controlling of the history of my code. But like for example here, if I keep both changes, I will have two strings with the same variable name, which will end up in an error. But Git doesn't care about that. Like Git is only trying to figure out what to do with those two changes. So I will keep this one, for example, and I say, yeah, I like that. This is how we should do it. This was a previous change that someone did, but we don't really need it anymore, for example, and I can hit save. Once I hit save, it will say, hey, perfect. Once you did that change, all the other files were committed successfully, and we did the merge. The merge has been successfully done, and here you will have again this. I didn't hit correctly. Here. Sorry, it's. Oh, I need to. For some reason, this should just keep this one. Yeah, I'm saving it like this, and I'm going to put it here. So I'm just gonna make sure. You see, this is what I was telling you. Okay, so right here, this is one of the things. It's actually pretty good that just showed up, um, because sometimes the user interface tools have some trouble. This is an example of one of them. Like in what it normally should be doing is if I'm gonna just show it again. When I go here and I open this file and I select my change, sorry, I'm gonna open here a little bit more. Yeah. And I hit save, it should save it, but it should keep it as a new commit. Because it's not doing it, it's like, oh, I'm not making your change. So that's kind of a bug on the tool right now. It's probably one of the latest changes. So it's having that trouble. So what I'm gonna do is I'm gonna go ahead and mark it as a result. I know what's the problem because it already showed me. And I can just go here into code. And this is what I was telling you, that Git, when you don't have user interface tool, Git is still giving you the hints of what's the problem, what's the merge conflict. So here is showing me that what are the changes. Like here is showing me here in your head. Head means my local branch. In my local branch, I have this string, but it's conflicting with the same string in the old branch, remote repository. So I gotta make sure to say, okay, I just wanna get rid of this line. I don't want it anymore, right? So we just go on ahead and remove it. But I also have to remove those like warnings, because those are just from Git that Git adds them into the code for you to know where to change. So I will go ahead and save my code. I will go here. I will have to stage this, and it's not saving it for some reason. Um, yeah, I will just commit this for now and go ahead and do that change again. So I just have to remove this and remove this. Save and make that change so we don't have those errors. So this is merge fix from same line editing. And I now, if I pull, it doesn't tell me that I have anything else to worry about. Everything is up to date, and I can push those changes to the server. And if I go into our nice GitHub and I refresh, I will be able to see that my change was successful, and I don't like the merge conflicts. That's why I say I don't like the merge conflicts. So the ideal is to avoid as much as you can the merge conflicts. Like try to do that as much as you can, because that will start creating these kind of like branchings and troubles. One excellent way to do it is before you start committing your changes, check out what they change. So I'm gonna do like a way on how you should do it properly. And Git Kraken has a tool to help you do that before getting to the merge conflict, because the merge conflict is something like not like, it's not nice. Try to avoid it as much as you can. So I'm gonna go here and I'm gonna go edit it again, right? And I'm going to say, but I don't, but I really like them. This was the guy that liked them. Adding again more message to the string on test. this will generate a merge conflict if not deal properly. And we know we want to avoid that as all cost. So we go ahead and commit that. We have our change. We go here. We don't see it. We will go and go fetch. And we have now our change. So we have now that line there. What we're going to do is we're going to go ahead and change it as well. Please avoid merge conflicts at all cost. Go ahead and save it. And I'm going here, and what I'm seeing is, oh, I changed this, but someone changed exactly the same line. Oh no, so I know this is gonna make a merge conflict. So what can I do? Like, oh no, I don't wanna lose my changes, right? Because I know my changes are the ones that needs to remain at the end. Because this one is probably something all like this guy added it, but then we had a discussion as a team and we decided no, we are gonna go with the new changes, but I didn't pull before I started doing the changes, and that's something that happens very often, you will see. So one way to avoid this is I'm gonna use this night button that is called stash. What it does is basically will save those changes, uh, but it won't show in my local. So I'm able to pull other changes, change my code, but I still have all those changes saved somewhere. So let's go ahead and I hit stage. So I can see here work in progress on the all master, that's WIP, and I see here my stages on the all master, right? So if we go ahead here, it will ask me, yeah, you need to change, and my changes are gone. So I'm back to normal. I didn't do any changes. So what I'm gonna do is now I can go hit, let's do something. Yeah, let's do something to show it better. So we are here, right? We have this change. Maybe we didn't see that this will cause a conflict, right? So I'm gonna hit pull on, oh no, there is a conflict, right? And I'm gonna choose first this one from here, and it's telling me, yeah, there is a conflict between your code, guys. So it's like, okay, what can I do here? So I'm gonna keep just them for now, just for the sake of this one. I'm gonna save this one and we will do it again. So this one was a successful merge using the git merge tool, but it's not often the case, right? So I'm gonna push this again, so the other one will have it. But now we are actually going to do is prevent that merge from happening, like that merge conflict from happening. So we will go here and we will go down here, and I'm gonna just remove this conflict, add more text on string variable, commit, and I'm going here into my branch. I'm gonna check it out, and yes, I have that change there. I'm gonna go ahead here and I'm gonna say that way you won't lose any content, right? And I'm going here and we have the same panorama, so we know we have changed exactly the same line again, which of course this is not just for like a little line, like this could be a lot of lines or like maybe some more complex objects. So we are gonna go ahead and select the stash option that we said. We have the work in progress, so we lost that change. We'll see, whoop, it's gone. So I'm back to normal as it was before. I'm gonna hit pull and I'm not gonna have any troubles because my branch was clean and I was able to pull. So it's gonna tell me, oh, conflict, conflict, right? But we know we don't want this conflict. We wanna have the other one. So what we can do is I'm gonna just say, hey, I want to pop this stash. Uh, this is actually happening because we had two pops at the same time, but we wanna keep this one, right? And we have our change here, nice and done, removing the conflict and adding the please avoid merge conflicts at all costs. That way you won't lose anything. That's beautiful, right? So what we want to do is we are gonna merge so of player controller string. I'm gonna get rid of these ones just to be sure. And I can pull, I don't have any troubles, and I can push. So in that way, we ended up having our changes all nicely done in our code. And we can go work collaboratively. Okay, so we are getting to the end of the session. Um, this is pretty much what I wanted to show you at the beginning for Git and version controlling and collaboration. Um, this is a really powerful tool. Uh, Trust me, at the beginning, you might have some troubles with it. Mm, all the user interface sometimes have bugs. That's why they keep posting new updates because it's normal, right? But it makes life way easier if you have it like this. But as I was telling you, like you will may have some troubles at the beginning. It's normal. Don't get frustrated. If you start running into serial troubles, please just let me know. I really love Git and I will be more than glad to help you out and try to solve those merge conflicts and those kind of things. But I really hope you guys go ahead and give it a try in like to to this website and install Git, generate your SSH key, create your GitHub account, and install Git Kraken or SourceTree or the GitHub desktop, whichever you prefer. I'm gonna show you real quick here. This is how the Git desktops look like. It pretty much does the same. Here you have your projects. I'm here on the same project that we were using. Here you will have your changes of like whatever you have changed on your project. So just as a quick demonstration here, if I add thanks for this first class, right? And save, and I need to go to here. I can see all those changes and everything that we have been dealing in this time. So that's how things work. Here it's pretty normal. Um, in the history you have everything, so it's pretty much the same. Like once you start working on it, you will see it will work exactly the same as it works on Git Kraken. It's just that I like from all of them, like in my personal opinion, the best way to go will be the command line. Like that's what I use most of the times. Is the best way to go, but of course that's not for everybody. Like the command line could be overwhelming and very tricky to use, and if you get an error or something, it could be bad. um, but I really encourage you, like if you have the time and you wanna put some effort into it, learn it. That will be great for you. But like then, if you ask me on like a user interface, good option. Uh, Unfortunately, all my bets goes for Git Kraken, even though it has some troubles as we saw, and it has some bugs. It is still for me uh, be the king. It's one like the best above all. All right, so if that's it, on Thursday, I think this is the one. So on Thursday, we will start looking into our part two of this course. We will start now diving into Unity. So for those ones that were really looking into Unity and how to make your first game, this is where we start. We're gonna start looking at that editor that I just showed you that might be a little bit like huge, like, oh, what is all of that? What is all of those screens and all of those things? We are gonna cover those on the next class, and we're gonna go here from the very beginning, like how to download Unity, how to activate it, how to create your first project, how to set it up, because, and of course we're gonna do it setting it up with Git, because as you can see here, my second commit, like the second thing that I added to my project is something called git ignore. We're gonna cover it more next on the next session, but it's something really important. Basically, as the name says, is a set of rules that Git will use to ignore some like files and folders in our project. Why is that? Is because not all of the files and folders that we have on a project are like needs to be shared in the cloud. A lot of things that a Unity project has are created when you open the project in your machine, and kind of they are like unique to your machine, and there's no need to push them into the cloud. Like it will just be a waste of space, and it will take longer for you to then pull the project. So as you can see here, I want to show you just quickly. If we go back to our project, sorry. You see there's only assets, project settings, git ignore, and readme. But if you go to my folder, there's like a ton of folders here, right? There's a bunch of more things that you really don't need. Like for example, my .bs, this is because I'm using Visual Studio. But maybe the other developer doesn't use Visual Studio, is using Sublime or Atom or whatever other IDE. So they don't need this folder. It's just for myself. It's just for my configuration. The same as the solution. This is just a Visual Studio thing that it creates. Um, and some of these folders are created by Unity, like the libraries, the temp folder. They are just created when you open the project in your computer, but you don't really need them in your Git repository, like in your remote. So that's something that we will cover on how to make that git ignore file, which is very important. If you don't use it, you will start having a lot of like changes in your branches here. Like you will change the README or something like that, or you just change like a file, and a bunch of like files will be shown there. Like you change a bunch of things, this and this and that, and those are things that you don't really care. But that's something for the next class. I hope, guys, you really enjoyed it. Once again, if you have any um, questions, please just let me know. I will give you my thing, like my contact information. If you really want like to chat or something, I will be open for it. I'm gonna just paste again here in here, like the website for you guys to try it out. The game, you kind of like play on what we will be building. But yep, basically that's it. If you guys also can give me some feedback on this first class so I can improve for the next one, feel free to tell me whatever you think, and I will try to improve for the next one. That's I really enjoy doing these kind of things, and want to share all I know with you guys. So yeah, thank you so much for tuning in and for being with me this night, and hope to see you on Thursday.